So hello everyone, hope you're doing well and welcome back to my channel. Today we are at day 21 of the May Daily Leetcode Challenge and we again have a medium level question in front of us. It's again a question on graphs. It's really interesting question and you will learn a lot of things if you solve this question. Let's see what the question is. It's question number 934, shortest bridge. Okay. So what they're saying is we are given a n cross n binary matrix. Binary matrix means it has only zeros and ones present in it. It's a square binary matrix. Okay, they are calling it as grid. You can just first see what the input is. They're giving a grid array, which is a two-dimensional array, and it has only zeros and ones present in them. Okay, what they are interpreting it is that one represents land and zero represents water. Okay, here I have clearly mentioned those things. Okay, so that we do not forget them. And the other thing is, see, they're defining what a island. See, one basically represents land and zero represents water. Okay, so now they are defining what a island is. Okay, so island is basically four-dimensional connected groups of ones not connected to any other ones. Okay, so what they're saying is, see, here dimensionality is very important because, because when we are discovering an island, let us we will understand this when we stage the examples. But remember one thing: here they are specifically mentioning that it should be a four-directional one. Okay, we should not consider the eight directions here. Okay, only the four directions. What are the four directions? Up, bottom, okay, right and left. Okay, these are the four directions we have to consider. And one more thing is there are exactly two islands in the grid. Okay, you may change zeros to ones to connect the two islands to form one land. Okay, return the smallest number of zeros you must flip to connect the two islands. So what it means is, see, it's very simple thing here, as you are seeing here. Okay, A represents the island A. See, actually both A and B will have values 1 present in them. Okay, and the blue thing which you are seeing here is water. It will have zero values. Okay, this what you are seeing is a grid. Okay, so all the values will be 0 except this what you are seeing A here will be 1, what you are seeing B here will be 1. Okay. But they why we write A here, because I am calling it as island A and this is the island B. Okay. And this is our interpretation. There is nowhere A or B given in the question, okay, in the input. We are interpreting as island A, we are interpreting as island B, and then we have to find the shortest distance between them. Okay. As you can clearly see in the left, this is the first example. Okay. In this case, the shortest distance between them is 3. Okay, there is no other way to get, see, from here also you can connect a distance 3. So there are many ways to connect it, but the shortest of them will be length 3. Okay, you have to make a bridge basically between them of length 3. That means, you see, here basically zeros will be there initially. You have to flip those zeros. You have to make a land. You have to flip zeros to 1. That means you have to make them as a land to connect the two. Okay, so basically you have to flip three zeros. So here the answer will be 3. Coming to the example at my right, okay, you can clearly see the A represents the land, sorry, island A, and the B represents the island B. If you try to connect them, you can clearly see that at least a bridge of length 5 is required. Okay, you can clearly see the ones here in this line. We have to make 5, or you can also see the bridge can be anyway in the four directions. Okay, it should not be a diagonal one, but any other along the four directions you can take any direction. Okay, but ultimately you take the shortest one. Okay, also I think you have to have answered the question by now. The question demands that how many zeros you have to flip. That means how many waters you have to convert it to land, how many water nodes you have to convert it to land nodes, so that the two can be connected with the shortest bridge possible. Okay, that is the question. Now coming back to the question. So yeah, that was the question, and I think you are see, tracing the example is, there is no meaning here because we can't visualize them. So ultimately, what I explained is that is the one we have to find the shortest possible distance between the two islands. Okay, and basically they are saying to convert flip them, so they are the way of they are asking is you have to flip the zeros to 1. Number of ways to do that in a, I mean, smallest possible way, so that we get to connect the two islands. Okay, so first of all, let me tell you what are the problems we are going to face here. The first problem which we are going to face here is that we have to differentiate between the two islands, because see, both of them will have, if you see the grade values of both the island and island B, all of them are going to be 1. We have to find a way to differentiate them. Okay, that is the first challenge which we are going to face. The second challenge that I should see, uh, I should not, for example, see, I when I'm at this any node of the island A, I should know what are the other nodes of island A. Okay, because that I should not confuse it between the next island. Okay, for example, see, this is island A. Okay, I should know what are the nodes present in island A, so that while finding the minimum length, I do not confuse between a node which is already present in island A as a node of island B. Okay, that is the next difficulty which you are going to face. Okay, so what are the things? First, we have to discover the elements present in each of the islands. Okay, what are the nodes present in each of the islands, indices present in each of the islands? That is the first difficulty. Second difficulty is we have to find the distance between them. Okay, So there are very nice approaches discussed here. So this is for the approach for the first difficulty. Okay? First, we will try to find the nodes in my each of the islands. Okay. So how we'll do that? We are going to use a DFS approach between them. See, suppose this is my island given to me. Okay. So what I'm doing is DFS approach means, see, DFS. If I have to tell you in a visualized way, we will keep going. See, PFS means we will first cover all nodes at at distance one, then all nodes at distance two, and so on. But DFS means we'll keep going along one direction. Okay, that is the idea. So see, here if we are starting at node 0, okay, so what I will do is I will try to discover the land nodes around this node. That means, see, if suppose this is my island A, okay, so how I will find if the nodes are present in island A or not? I will try to do a DFS along the four directions of the node 0, okay, up, down, right, and left. Okay, so suppose I come to 1, okay, because this is the only one among the four directions which is the land node, so I will come to 1. Okay, similarly, I will take in one direction of the node 1, and I will see if it's a land node or not. If it's a land node, I will again do the same for that. Okay, so now I'm come to 2. From 2, I will go to 3. So see, any one direction. DFS means choose a node which is a land and then proceed along one of its direction which is a land. Okay, that is what the idea is. And if it's, see, it will backtrack also. If you have to understand what is DFS, first you should see what is BFS. Okay, that should be the way. Okay, for example, see, this is the zeros which you are seeing here. Let us say it's the island B. Okay, what we are doing is BFS means we will try to cover all nodes which are dissonance. You can see the layer 1 is coming here. Okay, that is what is BFS. Okay, this is what is BFS. Now see, after 1 it came 2. Okay, so all the nodes which are distance 1 will cover now, all the nodes which are distance 2 will cover in the next iteration, and so on. Okay, that is what is the idea. But in this case, first of all, to discover the nodes within the island, I will use DFS, and for next thing I will use BFS. Okay, see, once I have discovered all the nodes within my island, now I have to find the shortest distance between the two group of islands. So in that case, what I will do is I will use the BFS approach. BFS means, see, for example, this is going to be my island. Okay, what I will do is I will try to find the nearest water nodes along it, which are at distance 1. Okay, so you can clearly see I found that using BFS. How we will do that? We'll see in the code. Okay, this is the one. Okay, next thing is, again I will see, till now I have not used that. Okay, so I have to do one more iteration. In the next iteration I will do one distance further, so all nodes which are at neighbors of this one will come. See, all nodes which are neighbor of 1 and water nodes will be now identified. Okay, which you are seeing here. Similarly, I will keep on doing this. Okay, now it's time for the number 3. Okay, so all nodes which are now water nodes and neighbors of this node marked 2, okay, it will come here. And you can clearly see we have now reached we are now almost at the boundary of the island B. Okay, so this is going to be the shortest distance. You can clearly see the yellow marked portion is going to be the shortest distance. How we'll code it, we'll see that, but this is the basic idea. So remember one thing, we had two difficulties, and what are the solution for that? See, the first difficulty was how to identify the nodes within the island. Okay, so for that we are going to use DFS, and for next difficulty is how to find the shortest distance between them, the two islands. For that we are going to use BFS. Okay, let us see how to code it further. See, the code will make it very clear for you. Okay, so the first thing is, first, see, when we are given the grid, we don't know where the island begins. Okay, the first part starts with finding a land node. This is what I am doing it here. Okay, first I am taking the length of the grid, because it's a n cross n grid, so taking length along one direction will give me n. Okay, the next part of the this code is I have to find any one land node to begin with. Okay, any one land node. Okay, so what I'm doing is I'm creating two loops, one inside other. Okay, it's a n cross n loop. That means we are going n square of n square loop. What we're doing is we are going to see it's a two-dimensional grid, right? So I need two for loops to go through each of the indices. Okay, each of the nodes. I am checking if the grid value of that is 1. That means if it is represents a land node. Okay, as I told you, I need to find at least one land node, right, to begin with. So I am recording a syntax in f of x and f of y. What fx and fy means is that it's the first x and the first y to begin with. Okay, first x and first y to begin with. Then we're breaking out of the loop. Okay, as soon as I find a, please try to understand this thing very carefully. It's a very, very easy question. Okay, this part of the code is to find the first land node. Okay, once we find the first land node, we'll break out of it. Okay, I am recording the index in f of x and f of y. Okay, initially they were initialized to -1, and then we are showing the index of the first identified land node in f of x and f of y. Then we're breaking out of it. This is the first part of it. The next part then lies in identifying the, see, there are two islands. Okay, this particular index which we identified belongs to any one of the island. Okay, so what we'll do to differentiate between the two islands is that, see, whichever island this particular index belongs to. Okay, what I will do is I will make the, see, it will obviously it will be one, right? This value will be one, right? All nodes belonging to that particular island. What I will do is I will make them as value 2 now. Okay, so try to understand very carefully. There are two islands, their values, each of the nodes belonging to those islands will have value 1. Okay, I've identified a one node of any one of those islands. What I will do is I will make the value of the island containing this particular node as value 2. Okay, so all the values of that particular island, nodes having that in that particular island, will now have values 2. Okay, this is done to differentiate the island from the each other. Okay, what I'm going to say is, see, this is the island, let us say island A and island B. So what I will do is, now all these particular nodes will be having a value 2 instead of 1. Okay, one was to make them as identify as land node, but I already know them as a land node. To differentiate it from the other island, I am making its value as 2. Okay, now for this the value will remain 1 only. That is the basic idea. Okay, so yeah, we will use DFS to discover land nodes from the current island. Okay, so let us say A. We'll differentiate the islands A and B by making nodes of A as 2 and add all the line nodes. So then we will start with BFS. Okay, what we are doing is, see here, I am going to start with a DFS of the index I have identified here. Okay, see, one thing is very clear, that f of x and f of y belongs to a land node in any one of the islands. Okay, I will start a DFS as I showed you in the example. Okay, as I showed you, this is what I am going to start with. Okay, to identify all of its nodes. Okay, so that's what I am doing. And as soon as I identify them, I will be inserting them into a queue for the next BFS round. Okay, say this is TFS and this is for the BFS round. It will not be used here. Okay, so what I'm doing is, see, as soon as I identify a land node, what I will do is I will make its value as 2. Okay, then I will insert it into a queue. Okay, then I will identify its neighboring nodes along the 4 directions, because in the question is clearly mentioned we drew along the 4 directions. I will identify its neighboring nodes along the 4 directions. These nodes may be out of the current grid, or it may be a water node and something like that. Okay, so I will check that if the CX and CY are in the range 0 to 1, that means they are within the grid. That is for checking that. And if they are 1, that means if they are also a land node. Okay, then I will again start DFS for that. Okay, this is the basic idea. So this loop will be run till I identify all the nodes in the current island. Okay, till I identify all the nodes in the current island, as you can see here. One thing, let me tell you that. Okay, see here, 0, 1, 2, 3, and 4 identified. Okay, after 4 there is no node, land node. Okay, so we'll have to backtrack. Okay, we'll have to backtrack. See, from 4 I will come back to 3, from 3 I will come back to 2, from 2 I will come back to 1, and from 1 then I will identify this particular node as node 5. Okay, again I have to backtrack to 1, and then the right node of 1 will be 6. This is how it is being done. Okay, so remember these things. DFS means you will have to backtrack. Okay, so that is what is being done here. This particular thing, what it will do is, it will identify for the, see, this index belongs to this particular node, belongs to island, right? I will make all the nodes of that particular island have a value 2. Okay, to differentiate it from the other island. At the same time, I will, like, I will maintain a queue which will have all the indices. Okay, which will have all the like indices of the nodes belonging to this particular island. Okay, which has this node. Okay, so I am calling it as island A. Okay, let us say this node is belongs to island A. Okay, the two islands A and B, and this node belongs to island A. What I am doing is I am making all the other nodes in that particular island A have a value 2, and I am inserting those indices of those nodes having belonging to that island in my queue. Okay, so this is all for that. Now the DFS is over. Okay, now my queue will have all the nodes which belong to that particular island. Okay, their x and y values will be in that. Now I will start with BFS. Okay, what was the reason to do BFS? As I explained here, BFS is to find the shortest distance. Okay, so I will start with, like, all nodes which are at distance 1 will include it, or water nodes at distance 1 will include it, then water nodes at distance 2 will be included, and so on till we reach the border of the other island. That is the basic idea. So yeah, I'm declaring distance which initially will be 0. Okay, and now this queue is filled. Okay, it will have all the nodes of the island A, their x and y values will be in that. Okay, so till my queue is not empty, this while loop will be done. What I'm doing is I'm creating a new while loop, new queue. Why I'm creating new queue? We'll understand this in the later examples. For now, I just think that I will be using this in the next example. Just this new queue will become the queue after this iteration. Okay, I will tell this why we need this, but for now, just ignore it. Okay. what I'm doing is I'm going through each of the nodes in my current island A, okay, whose value I've already made as 2, okay. What I'm doing is Cx and Cy will be its neighboring node. Cx and Cy will be its neighboring node along the 4 directions, okay. I'm just trying to check if Cx and Cy are in my grid or not, okay. What I'm doing, I will again repeat. I am going through each of the elements of the each of the nodes present in my island A, okay. Cx and Cy represents its neighbors along the 4 directions. I am trying to check if they are within the grid or not. If they are within the grid, do 2 things, okay. Check if that is a land node. If it is a land node, that means, see, value 1. Remember one thing, for the current island, I made all the values as 2. For the current island nodes, that is for island A, all the nodes will have value 2. They will no more have value 1. That means if I am getting an island node, sorry, a land node with value 1, that means it belongs to island B now. Okay. This particular thing belongs to island B now. That means we are at the border of it. That means return whatever the distance we have found. Okay. This particular condition will come then. Okay. This is when we are reached the border of the island B. Otherwise, what we are doing is, if that is, if the node is a water node, that means we have still not reached it. We'll have to do one more iteration. What we need to do is first make its value as -1. That means it's a discovered water node. We will not do it again. We will not discover it again. That's why make it as -1 and append it to my queue. This, see, remember one thing. I am appending it in my new queue. This time it's a new queue. Okay, not the old queue. This is the old queue, and this is the new queue. Before we begin this loop, Q will have all the indices, that means all the nodes of the island A. Okay. After we finish one iteration, it will have all the indices of the border nodes which are at distance 1. Okay. After first iteration, it will have all the indices. That means new Q will have all the indices of this ones which are present here, right? All the nodes which are present by 1 now, in this example, will be present in that. Okay. It will have all the border nodes, okay, at distance 1. That is the basic idea. Okay. Then once this iteration completes, see, we have inserted this all these border nodes indexes in the new queue. Okay, now new queue will replace with my original queue, and I will increase the distance by 1. Okay, so while I would have understood that the only thing which we are returning in this example is this. Okay, this is the only return statement present. Okay, so my answer will return from this return statement. So how it will return, this is how it is. Okay, see, please pay attention here. This is a really easy example if you really understand it. Okay, see, initially this is my let us say island A. Okay, in the queue, which variable which you saw now will have the indices of all these nodes initially. Okay, what I will do is I will try to see the its adjacent nodes which are along the 4 diagonal. See, whenever I say neighboring nodes, adjacent nodes along the 4 diagonal, that means you translate along the 4 diagonals. Okay, I will check if it is a water node. If it is a water node, I will include it in my new queue. Okay, so the ones which are seeing here, the nodes which are represented by 1, will be included in my new queue in the next iteration. Okay, then when we go for the next iteration, all the nodes which are seeing here with the number 2 marked will be now in part of my new queue. Okay, so then when we go to next iteration, these things will be like processed. Okay, now the nodes which are seeing with number 3 written will be now in part of my new queue. Okay, now this will be processed. Once I process the node with 3, you can clearly see we will have a node which value 1 coming into it. This is going to be return condition. Okay, this is going to be my return condition. So we are returning it. Remember one thing, we are returning it. Okay, see, while the loop gets over, only then we'll do distance plus 1. Okay, that means after we have identified all nodes with a distance 1, I'm doing distance plus 1. That means once I identify a land node, it will be returned. That means we'll never do distance plus 1. That means we are not going to add the distance of this particular node, the green node here. We'll be doing it before that. Okay, that means, see, it is at distance 4 basically. See, 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. But this will not be done. This will return before the distance is incremented. Okay, so we'll have only 3 as the answer. Okay, which you're seeing here in the yellow color. That is the basic idea. So yeah, friends, I will again repeat. This is for identifying the first land node. Okay, whichever island it belongs to, I will call it as island A. Okay, then I will do the DFS to get all the indices of it. Okay, then I will store it in the queue. Then I will process the queue, and for the next iteration, I will make a new queue, and then I will initialize the original queue with the new queue. See why I am doing like this? Because in Python, you cannot modify a list which is being like iterated through. Okay, see, in this case, I'm iterating the queue. Okay, so I cannot modify it while it's being in iteration. Okay, so I cannot modify it while it's in iteration. That's why I'm creating a new queue, and once the iteration is over, I'm loading the queue with my new queue. That is the basic idea. Okay. So this part is for discovering the nodes and inserting into the queue, and this part is for like doing a BFS traversal. That means including all the neighboring water nodes which are at distance 1 in the new queue, and in the second iteration all the neighboring nodes water nodes which are at distance will be included in the new queue, and so on till we reach a node which have a value 1. Okay, once we reach it, we will return the distance. Okay, that is the basic idea, and that is how we are finding the distance. So yeah, if you have any remember one thing, we are doing two things here. For the first like for this node whichever island it belongs to, we are making its value as 2. That is the first change which we are making. Next change is that whenever a water node is like identified and whenever it's inserted into the queue, okay, I am making its value as -1. After, remember one thing, after it is appended, I'm making its value as -1, so that it's not again identified. Okay, so no, it's not like again sent into the inside the queue. That's what it is. So yeah, fine, that was all for today. If you ask me the time complexity, see, we are doing BFS and then DFS, right? So the for time complexity, the time complexity of DFS algorithm is n plus c, where n represents the number of nodes and v represents the number of vertices. In this case, the number of nodes is n square. Okay. So because we are going to process n square nodes, and one more thing for this example also, suppose the n node is present at the last, we are doing 2 for loops. So obviously, it will going to be of n square. So in this case, the time complexity is going to be of n square, and come to space complexity. See, space complexity of a DFS or BFS is going to be O of V, okay, where V represents number of vertices, okay. In this case, number of vertices, that means if the whole thing is a graph, right, the whole grid is a graph, so the number of vertices itself is like n square, so the space complexity is also going to be of n square. So the time complexity and space complexity both are going to be of n square. So yeah, friends, that was all for today. If you wonder, please do comment below. But remember one thing: see, these kind of questions, don't think like you will not never be able to solve this kind of question if they come in an interview. Remember one thing: these kind of questions will come in interview. The interviewer, you will have to take the help of the interviewer. He will give you the directions. He will give you the hints that you will have to think of using a DFS approach to find the nodes of the current island, then a BFS approach to find the nodes for the distance. He will give you those hints. You will have to code them. That is what is the idea. Like, do not think that if this question comes in the interview, I will never be able to do it. See, never have this kind of view. These kind of questions will come only in the this will never come in the first round of the online process. Okay, this will come only in the when you have an interview in front of you. Okay, a one-to-one discussion. Only that time these questions will come, because this question requires a bit of discussion with the interviewer. Okay, this question requires a bit of hint to be given. Only then you can come to a decent solution. Okay, that is the one thing which I need to tell you. And yeah, friend, that was all for today. Thanks for listening. Thanks a lot.